In this video, we're going to look at how we solve chemical problems, and the techniques shown in this video we're going to use a lot, both in Gen Chem 1 and Gen Chem 2. So this is one key video that if you don't get, you should go back and watch. Alright, so most problems we see in chemistry are really just unit conversion problems. And the way that we solve unit conversion problems, it's called dimensional analysis. And just as a note, whenever you do calculations in this class, you need to have units. If you do not give me units for your answer, it is not complete and you will lose points. Now, what is dimensional analysis exactly? So imagine that you're looking to cook dinner and you find an amazing recipe on a website, but oh no, it's from England and they use a metric system and you're American and you don't know what that means. So it calls for 200 grams of an ingredient. Well, how many ounces is that? How can we measure that out? Well, to do that, we need what's called a conversion factor. And a conversion factor is simply a number that allows us to go from one unit to another unit. So in this example, our conversion factor is 1 gram equals 0.0353 ounces. Now, how do we solve dimensional analysis problems? Well, really, we have a standard procedure where you'll get some information given in the problem, and you'll either be given a conversion factor or you're expected to know a conversion factor. You multiply these two together, and you'll get whatever information is needed for the problem. And these are also checked by looking at the units. So you're given one unit, and you have a conversion factor that is your desired unit divided by your given unit. When you multiply something that is being divided by the same unit, those units cancel out and you get your desired unit. So to keep this straight, for me, I use what I call the train track method. So let's take a look at this for that gram to ounces problem. So we start out with 200 grams. Then we need our conversion factor, which our conversion factor is for every 1 gram, we get 0.0353 ounces. So then what I do, for all the top values, you multiply them together. Then for all the bottom values, you multiply them together as well. Note that this is a blank spot, so we're just going to assume that is 1. Then you divide the top number by the bottom number, and your units should cancel out. So what I mean by that is we have grams on the top and we have grams on the bottom. So grams will cancel out. And just note, for any dimensional analysis problem or like any problem in chemistry, follow your units. If your units don't cancel out correctly, you have done the math wrong. Your units will tell you if you're doing the math right. So let's take this concept and try to figure it out ourselves. So I have two example problems for you. How many millimeters are in 5.705 meters? And then if an object has a density of 5.32 grams per cubic centimeter, what is the density in kilograms per cubic meter? So I want you to pause the video now, try to figure out both of these problems, and come back when you have it. Alright, so let's look at the first one. So we're going to set up our train track, and we start with given information. We have 5.705 meters. We want to convert this into millimeters. Well, our conversion factor is for every 1 meter, we have 1,000 millimeters. And if you don't remember that, go back to the video on SIs, significant figures. Okay, so what we're going to do is we're going to multiply the top together, divided by 1. And notice what our units will be. Meters divided by meters cancel out, so our units is millimeters. and we get 5,705 millimeters. Let's go to problem 2. So we're given with 5.32 grams per 1 cubic centimeter. So grams on the top, cubic centimeter on the bottom. And I'm going to start the conversion for grams. And our conversion factor is for every 1,000 grams, we have 1 kilogram. Alright? Now that takes care of the numerator. Now we got to take care of the denominator. And for every 100 centimeters, we have 1 meter. But we're not done. Notice our units are cubic centimeters. That means we have to do this conversion a total of 3 times. So we do it once, we do it twice, we do it 3 times. Now let's take a look at how our units are going to cancel out. Grams cancel out with grams. We have 1, 2, 3 centimeters on the top, 3 centimeters on the bottom, so those units cancel out, and 1, 2, 3 meters on the bottom. So our units are kilograms per cubic meter, exactly what we want. So our first step is we're going to multiply the top together, and we get 5,320,000 kilograms. Next stop, we're going to multiply the bottom together, and we get 1,000 cubic meters. Now we need to divide these two numbers, and we get 5.32 times 10 to the 3 kilograms per meter cube. So I have my units right, and I also have my sig figs right, because our original value was given in 3 sig figs, so my answer also has to be in 3 sig figs as well. So the general strategy for solving problems, and not just unit conversion problems, but any problems. 1. Identify your given information. 2. Identify what you need to find. 3. Figure out a way to get from your given to your endpoint, your conceptual plan. And there's 4 steps for this. 1. Just sort and list what information do you have and what information do you need to find. 2. Strategize. Okay, now that you know the information that you have and the information you need to find, how are you going to go from A to B? Solve. Now, once you strategize, you just have to put that plan into action. And check. Do your units make sense? Are your units canceling out properly? Are the units matching with your endpoint? Do your numbers make sense? And when you do math, you should have a general idea what the number should be. Is the number really high and you are expecting it to be low? You probably made a calculation error. And are your sig figs correct? Go back and check all your significant figures. This should be your last step, and make sure you report your answer with the correct sig figs, because if you don't, you will lose points. Alright, that's it for this video, and see you in the next.